All right, today we're going to see how an application on the calculator can allow us to solve financial problems. I posted on the task a website that will allow you to do a similar thing if for some reason your calculator's dead or you don't know where it is. Um, the button presses are slightly different, so make sure you read the directions on the site if you're going to use that. So, in Algebra 2, you saw how to do some financial problems. If you had this problem, if you're investing 5,000, 6.5 years, 5.25% interest compounded quarterly, we would do it like this. We're going to see a way that the calculator will do it differently in an application. And the reason we want to use this application is, well, what if during that 6.5 years, you're continuing to invest more. This formula is only good if you only invest something at one point and then you just let it sit. Um, as we saw in the retirement investment things, a lot of times when you're contributing to say like a 401k, you're contributing a certain amount per paycheck or a certain amount per year. So you're constantly investing new amounts. So you're not just putting one thing up front and letting it sit. So therefore this formula doesn't necessarily help us that much. So we're going to use the TI Finance application. We'll show you how to get there in a second. These are the different things that we'll see. N is the number of periods that interest is compounded. I is our annual rate of the interest. PV means present value. Periodic payment here, what it'll end up in the end, the future value. And then the number of payments per year. So if it's quarterly, PPY would be 4. If it's monthly, PPY would be 12, and so forth. So in our finance app, there's 4 or 5 variables that we'll have to work with, and you always fill in all but one of them. And then you put your cursor in the field that you want to find, and you'll hit enter. Financial calculators, the direction money is going is important. Um, we need to, if money is coming from your wallet, it needs to be put in as a negative. If money is going into your wallet, it needs to be put in as a positive. So for example, if you invest $1,000, that should go in as a negative 1,000 because $1,000 has come out of your wallet. If you were to borrow money, that would be represented as a positive because that's money that's coming into your wallet. Um, so always see if your answer makes sense because it's easy to type something in wrong. Um, and the PPY we talked about was like 4 if it was quarterly, 12 if it was monthly, and so on. And I can't remember if I mentioned a second ago, but this is all in the notes packet that is listed on Schoology. Okay, so let's start actually doing some problems. So your work, because eventually we'll have a quiz on this, will be to have the box and to fill in each of the spots here. So on your paper, you can be writing this, and I'm just going to write it over on the calculator here. So on our calculators, we need to go to a calculator page. And then you're going to go to Menu, and then down to Finance, and we want the Finance Solver number 1. Uh, let me So I had just practiced this one a second ago, so let me clear those things out so we can see where they're coming from. Okay, so for n, n is our number of compounds. Well, we're doing it quarterly, and it's 6.5 years. So what's nice is you can do the calculation right in here. So we have 6.5 years times, we're doing it quarterly, and hit enter. Oops, sorry, don't hit enter, just click the next one. If you click the next one, then it tells you automatically that there's 26 compounds that will take place. The interest rate was 5.25. Okay, and just click to the next box, then you can tab through them. Um, for PV, our present value, well, we have 5,000 and we're investing it. So that's leaving our wallet. So we'll want to put it in as a negative 5,000. We don't have any payment here, so the payment, so we'll leave that as 0. The payment would be like if after each year you put in an extra $1,000, then you would put in minus 1,000 there for the payment. And the final value, or the PPY is 4 because we're doing it quarterly. And then notice the CPY automatically is 4 as well. Now, what the end represents, we'll do end for each of the ones we're doing. It just means that the payment is made at the end of the compounding period as opposed to the beginning of the compounding period. So we want to know the final value. So what you do now is you put your cursor in final value and hit enter, and it automatically populates what it is. So for our answer here, we would just have $7,017, and we'll use regular rounding rules, and it's money, so we'll have 0.93. So on your quiz, you'll eventually do, you'll just fill in each of these, and then you'll tell what your answer is. So that's your work. And all of these, end and begin are the two options. All the ones we'll have end. All right, so next one, suppose you have $5,000 and you want to double your money in 3 years. At what annual interest rate compounded quarterly will you need to invest the money? So we're assuming there's no additional deposits or anything. So I'm just going to delete these all out. You don't have to do that if you don't want. So we are still doing quarterly, so that PPY I'm going to leave as 4. So we want to double our money in 3 years. So we would do 3 times 4 to get the number of compounds. We want to find the percentage, so we're going to leave that for now. We're investing $5,000, so 5,000 is leaving our wallet, so we'll put negative 5,000 there. We are not having any payment, and we want to double our money, so we want the final value that we get out of our investment to be 10,000. So then just go up to the percentage and hit enter, and we get our percentage. So let's say we'll go to the nearest tenth of a percent. So that means we would have 23.8% in order to double in that short of time. Now there's something in finance that's called the rule of 72. So the rule of 72 is a rough way to estimate the doubling time. So what you do is you take 72 divided by the interest rate. We'll call it R for a second. So if I escape out of here, let's just try it with what we found. 72 divided by 23.8. It's about 3 years. Okay, so it's rough. It gives you a rough idea. So it's just a quick way of how you can determine the doubling time really quickly. All right, next one. Suppose Bank of America tells you it pays 2.8% annual interest, compounded monthly, and Oneida Savings Bank tells you it pays 2.8% annual interest, compounded annually. Which one is a better investment? In other words, which one has the higher effective annual yield? So what effective annual yield is it is the amount that you would get if it was done annually. So if it basically allows you to compare investments that have all different percentages and things like that. So let's look at the Bank of America one first. One thing we want to do is we want to change our PPY to 12 because we're doing it monthly. And to find the effective annual yield, we're just going to invest $1. So we're going to go for 12 months. Our percentage rate, they told us, was 2.8%. We're going to invest $1 because all we're trying to see is which one's the better one. And by doing one, or you could do something like 100, something nice, no payment, and then we want to see what our final value is. So we'll delete that out and hit enter. And so it looks like our final value, and we're going to keep it out for a few. So for Bank of America, we get 1.02836. So investing $1 there after a year will essentially give us that. Now in your work, because we're going to end up doing two of these, you can just list the ones for Bank of America here, and then maybe list the Oneida ones over there, or so. So the things that we have to change for the Oneida is we're doing annually now, so we want this to go down to 1. So how many compounds are there in the year? Well, if we're doing it annually, there's only one compound in the year. We'll delete that out because we're going to find that. Or sorry, no, they told us it was 2.82 for that. Again, we're going to pay $1. And now, oops, now the final value is what we want to find out. So when we hit enter there, we get 1.0282. Okay, so we want to know which one's the better investment. Well, Bank of America is the better investment because if you look, you get a little bit more. So basically, 0.00 0.00016 more of $1 you'll get from Bank of America. So essentially what this is showing is Bank of America's effective annual yield would be 2.836%. So getting 2.8% monthly is the same as getting 2.836% annually. So it has a higher effective annual yield than the Oneida one. Okay, so here's the big reason why we want to use the finance calculator is what if you're regularly contributing? So Susie's going to give $100 every month in her bank account, 4% compounded quarterly. How much would she have after 20 years? Well, in our basic formula you learned in Algebra 2, we wouldn't be able to use that because that only puts the money in and just lets it sit. You're not contributing something new each time. So this could be done with a spreadsheet, but you'd have to like recalculate it each time, which would be annoying. So we're actually gonna jump ahead to number 4 now. And the reason we're gonna do that is this one, how it was described, it's at 100 at the beginning, and all the other ones we're going to do are at the end. So that's why we're going to skip over that one. So go ahead to number 4, and we'll look at one that has a payment now. So we're going to pay $1,500 each month into an annuity. Annuity is just a type of investment. And the interest is 6% compounded monthly. How much will you have at the end of a 7-year period? So I'm going to delete all these out. Okay, so we're doing each month. Okay, it's the interest is compounded monthly. So let's start with the PPY. We would want that to be 12. Well, we're doing 7 years, and it's compounded monthly. So we would want to do 7 times 12 here, and that would give us our number of compounds. The interest rate is 6%. So we're doing 1,500 each month. So at the very start, there's actually nothing in there. So our present value is 0, but then the payment we're making out of pocket, we're paying 1,500 each month. So that would be a negative, and then we're going to end up finding what the final value is. So if you hit enter, this gives us the final value doing those payments of 1,500 a month into the annuity and then getting the interest on it. So our final value, we got $156,110.89. Okay, next, suppose that you have $1,200 today and you're doing 500 a year invested. Assume that you get 8% annually invested. How long will it take for the investment to be worth $10,000? So delete these out so we can start fresh. So first off, we are doing annually here. Didn't say monthly, quarterly, anything like that. So we'll put our PPY at 1. We don't know the N. We want to know how long the investment needs to be. So we're going to leave that. That's what we'll solve for in a second. We wanted 8%. So we have 1,250 today, but that was invested. So we've got minus 1,250. Then our payment, we're doing 500 each year. And we want the final value to be 10,000. Well, to find how long it'll take, just hit enter. So about 10.05 years. Now again, on the problems you're going to do on your own and on the quiz we'll eventually do, I would want to, you need to just fill in what these are. And each time we're doing n, so you just circle n, and then just write what your answer is. Your work is just writing what it is that you put in the calculator. All right, one last one for this video. So you're planning to send your daughter to college in 18 years. You assume that you will need 280,000 to pay for tuition, room and board, and everything. If you have 10,000 to invest today, and you're going to do 5,000 a year after that, what compound average annual rate of return do you need to reach your goal? Okay, so let's delete all these out to start fresh. So it didn't say anything about monthly, quarterly, anything like that, so the PPY will leave at 1. We're doing 18 years from now. We're going to find the interest rate, so we'll leave that blank. You had 10,000 to invest now. That's coming out of your pocket, so it's a minus 10,000. You're going to invest 5,000 a year. It's coming out of your pocket, so it's a minus. And your final value, and I didn't really do a good job mentioning this in the last one, but the final value, that's what you're pulling out of your investment and is now coming into your pocket. That's why that went in as a positive last time. So 280,000 is what you then pull out of the investment at the end, coming into your wallet, so it's a positive. We want to know our percent, so we hit enter. So we would need about 9.89% in order to reach that goal. All right, that's the end of the day 1 video. Your next task will be to do some practice problems.